When a surfer, like myself, first enters the water, the physics of the situation starts right away. One factor that helps the board displace water is its size and light weight. Looking at the free body diagram on slide 4, it shows how gravity pulls downward on the board while buoyancy pulls upward, which is equal to the weight of the displaced water. This allows the board to stay afloat. But since the person on the board has a mass and buoyancy isn't strong enough to keep both the board and person afloat, another force of hydrodynamics acts upward as well. The perfect wave. It's what all patient surfers wait for. Waves are able to form by transfer of energy. Wind factors into this acceleration by accelerating water particles, which become ripples and then grow into waves. Gravity acts downward, trying to pull the waves back to its normal position, but particles push against each other with pressure and form energy in the water in unison of wave motion. The stronger the wind, the higher the white caps of the waves are, and this makes sense because after a storm, it tends to be larger waves. Tides also contribute to the formation of waves as the pull of the moon's gravity goes onto the earth. So the waves form, but now what? How do I stay afloat and then catch a wave? So this part tends to be a little tricky, especially with the chaotic motion of waves which form torques on the board. To counter these vicious attacks, a surfer must apply their weight in a particular direction in order to create a torque in the opposite direction of the waves to cancel out the rotational forces and avoid hitting the water. Newton's first law applies to waves that are in motion and tend to stay in motion, while a floating surfboard tends to stay at rest. This is why a surfer has to paddle to catch a wave. According to Newton's third law, every action has an equal and opposite reaction. When a surfer pushes down on one side of the board, that side pushes into the water, which pushes back up against the board. As a result, the board starts to turn. So this is progress. The turn is needed to pivot the board in the same direction of the wave. So I'm in the right direction. My heart starts to beat faster as the wave I've been hunting for finally approaches. So how do I catch it? The key of this is timing it correctly and matching the speed of the wave. The board will then form an angle with the water, which creates pressure on the bottom, allowing you and the board to stay along the surface. When hitting the bottom of the wave, you should feel pressure pushing forward and upward. The culprit of this action is the hydrodynamic force. Woohoo! I caught the wave! Now begins the fun of it. So the increased forward momentum helps stabilize so I can pop up and stay up. It's important to find the correct ratio of balance and speed in order to stay up for longer and keep a good speed. The bending of the knees also helps with this. If the wave begins to turn though, the surfer may need to shift their weight in order to apply a torque and maintain a parallel path to the shore. The fins also help this by repositioning the weight while also adjusting the speed and direction. I hope that helped you understand the physics of surfing so you could go catch a gnarly wave of your own. So I'm gonna head out and catch my own wave, so I'll talk to you later.